Hello everybody! In this session I will introduce you to the types of digital image in remote sensing. On this slide you can see a list of all types of image used in remote sensing, which will be defined in the rest of the presentation. At the beginning I will define term panchromatic image. It is a record of the radiation intensity of a wider part of the spectrum, or the entire range of radiation for which the sensor is sensitized. For example, the entire range of the visible part of the spectrum is used to create an RGB color image. This radiation intensity is shown by shades of gray. Panchromatic images are created with the best spatial resolution, because the energy range of wider spectral range makes it possible. In contrast, a multispectral image is created by energy of a narrow part of the spectrum within certain wavelength range. For example, 3 images are created within the visible part of the spectrum: blue, green and red. Multispectral images are useful for distinguishing features of object in the scene. Panchromatic and multispectral images are single channels digital image. On them, pixel values are displayed in shade of gray, black and white images. Unlike them, color images consist of 3 multispectral channels showing the same area, each representing intensity in a different region of spectrum. Unlike single channels, digital image, whose elements is the matrix, are scalars. The elements of a color digital image are ordered triples. 3 pixel values, as you can see in the image. In the upper left corner of this slide, you can see displays of 3 multispectral digital images and their visualization. On the right side of the slide, different combination of pixel values of the color image are shown. If all 3 channels have the maximum pixel values, 255 in 8-bit image, mixing them with results in the white pixels in the image. If all 3 channels have a minimum pixel value, 0, mixing them will result in black pixel in the image. Any other combination of 3 pixels values in a color image will result in some color, hue and saturation of the color. The highest number in the orders tripled of pixel values will determine the color, and the other 2 components will affect the hue and saturation when it is combined. A color image created from 3 8-bit image can display 16 million and 16 colors of the pixel. On this slide you can see example of the panchromatic image and 2 color images. In the middle there is a so-called RGB color image that show the environmental in the same color as the human eye. Such display is called the true color RGB image, because the red part of the spectrum is taken from the R channel, the green for the G channel and the blue part for the blue channel. However, in the RGB form, 3 of any other channels can be combined. In this way, the third image was created, in which are combined infrared, red and green channel. Such color image is called color infrared or false color. On this slide you can see a single channel panchromatic image, black and white, or the left part of the slide, and the RGB true color image on the right side. The spectrum range used for their creation are also shown schematically. We know that photos travel at different wavelength and interact differently with the same object in the scene. This can be clearly seen in this slide, showing different multispectral images of the same sensor. Daedalus spatial resolution 1 meter. For example, one can see how vegetation is displayed in the visible part of the spectrum and how it in the near infrared part of the spectrum. You see the blue, green and red, and down you can see the near infrared part of the spectrum. In the infrared spectrum, it is shown much brighter, which means that the reflection in this wavelength is much stronger than in the visible part of the spectrum. Sorry. The infrared wave region of the spectrum is defined in the range of wavelength from 0.7 micrometers to 100 micrometers. To create thermal image, thermal sensors use mainly radiation in the wavelength range from 3 to 15 micrometers. The way to create a thermal image is fundamentally different from the creating an image with reflected energy in the physical sense. The creation of thermal image is influenced by the postulates of thermodynamics of objects. The picture on this slide shows the daily temperature movements of the main object classes on the Earth's surface. The first thing that can be noticed is that the temperature of the soil changes much more than the temperature of the vegetation and water. During the day, the soil heats up more than the water, but it also cools down more at the night. The next important fact that can be seen in this picture is the similarity of the temperature of all objects at local sunrise, morning, and local sunset, evening. On this slide, you can see the thermal images and their applicability. The image in the upper left corner shows a thermal image of petrochemical facility and how its activity increases the temperature of the Delaware River next to it. The image in the upper right corner shows the soil temperature of Dala, Germany, in winter left, spring middle, and summer right. The picture in the lower right corner shows the insulating sheet on the power line pole where the losses to electricity can be noticed. The bright part of the picture gives information that the insulating sheet is not good and that electricity is being lost in that place. The fourth example of thermal image applicability in the lower left corner further illustrates the differences between images created by reflected and emitted energy. RGB color image shows two metal containers for liquid. Can you tell which container has the hot water? Hardly. You can see that from that some picture RGB. But what do you think now? Brighter pixel show the warmer objects on the thermal image. In addition, it is possible to see from which container the liquid is poured. That is where the liquid was spilled. Dark parts show lower temperatures, and when the same object is soaked in liquid, it appears darker in the image. So the radar transmits a microwave signal towards the target and detects the backscattered part of the signal. The specificity of the radar operation is that it collects data oblique relative to the vertical to the surface, or nadir. This way of recording causes the display of objects in relation to their position in environment and its surface. Namely, tall objects with reflected a stronger signal toward the antenna compared to low ones. Rough object will reflect the signal in all directions, while smooth object will reflect the signal from the sensor. Therefore, tall or high objects will be bright in the images, rough object will be less bright, it's gray, and smooth object will be dark. Semantic representation of reflection from different objects can be found in the image on the right part of this slide. On this slide you can see example of the previously described models of reflection and how it can be seen on radar images. The spectral resolution of the image indicates the ability of the sensor to recognize a small part of the spectrum and store this energy as an image. High-speed spectral images have a much better spectral resolution than multispectral one or panchromatic one. For example, for the green wave region, the multispectral image covers a part of the spectrum from 0.5 to 0.6 micrometers, which means that this spectrum resolution is about 0.1 micrometer. The spectral resolution of high-speed spectral sensor is an order of magnitude smaller and can be as low as 0.01 micrometer. Due to this fact, hyperspectral systems can create hundreds of channels of one scene at the same time and store them on one file, the so-called hyperspectral cube. The differences in spectral resolution and number of spectral channels is illustrated on this slide. Once again, multispectral images have a worse spectral resolution and a smaller number of channels, about 20. And hyperspectral images have a better spectral resolution and much larger number of channels, that can be over 200. Depends on the sensor. That would be all for this presentation. Thank you once more for your attention and see you in the new presentation. Bye.